Hi, I'm Andrea and welcome to Productive C#. In this video, I'm going to tell you how you can manage input with keyboard and mouse in GoDot, and also how you can manage collisions using the GoDot physics engine. Let's get started. I already have a pre-built game. If you press play, you can see that it's already positioning a main character on the screen, plus is adding randomly different stars on the screen. What I want to do is to change the code to provide a way to move the character using the keyboard, and also to change his size using the mouse, and plus other things we're going to do along the way. Let's get started. So let me show you the code. I have a game scene, a player scene, and a star scene. A player scene is already positioned in the game scene, and it's made of a few different nodes. I'm going to go into detail of that later. But for now, consider this player and star as just two nodes that we are going to control. Let me go back in Visual Studio, and you can see the game class is getting a reference to the player, and also adding 20 instances of stars. Each star is getting the size of the screen and positioned itself randomly on the screen. Okay? Now, let's go back to game, and here I'm going to add the logic to detect when a key is pressed and makes the character move. The first things I want to do is, when I press the letter A and D, I want the character to rotate. Let's start with that. Handling the input in Godot is extremely easy. You use the input class. You can do input, and you can say if it's key pressed, and you can say key dot A, for example, and then you can do the code. I want to do the player rotate of mathf.py times t. So t is basically the delta, and mathf is a class that the framework provides to actually expose you the constant, like p as a floating point number. Here, I'm basically rotating backward at an angular speed of pi per second. Okay? I can do exactly the same when I press the letter D, but instead of minus, I'm going to do plus, basically rotating clockwise. Let's see what happens if I run this code. Now, when I press the letter D, it's rotating clockwise. When I press the letter A, it's rotating anti-clockwise. Easy and simple. The next steps is to actually move the character in the direction pointed by the character after the rotation. This sounds like quite complicated math, but I don't need to worry too much about it because I can use functions that GoDot provides to do that. So in order to calculate the direction, I can take the vector up and call the method rotated, and then I can specify the rotation of the player. So it's basically taking the vector pointing upwards and rotate it in a similar way as the player is rotated. So I have the direction vector now. So now what I can do is, again, using the input class, if the key button press is W, I want to go forward. And we know how to do that. I can do change the position of the character and adding the vector direction time a speed I want to do, like let's say 1,000 pixels per second, okay, in the direction of the player. And if I use the letter S, I want to do exactly the same, but going backward. So if I run this code, I should now be able to control my character completely. Rotate, move forward, and rotate. And you can basically move it as you want. Go back and forward and so on. Quite nice and smooth. Okay, the next step is, let's say I want to change the scale of my character based on the mouse button, left or right. So if I hold the left button of the mouse, I want to make the player scale. You can probably guess how this works. I'm still going to use the input class, and this time I'm going to say is mouse button pressed. And I'm going to say left. Okay, if I press the button left, I'm going to change the scale. Let's make it bigger if I press left, and I can use like 1 plus t, for example, as the value. So I'm going to make it slightly bigger, as big as delta. And if I press the right button, I'm going to make it slightly smaller. Okay, let's see what happens. If I press the left button, it's going to get bigger. If I press the right button, it's going to get smaller, and I can still move around. Excellent. So now you've seen how easy it is to manage the keyboard in GoDot. I want to do another keyboard binding. I want to make my player to follow the mouse when I hold the control button. Let's see how easy it is to do that. If is the key pressed, being key.ctrl, what I want to do is I want to change the player position to be the mouse position. And you can get the mouse position using get viewport, no rect, get viewport dot get mouse position. And now, as soon as I hold the control key, my character follows my mouse. Let's press control key, boom. Now, if I move my mouse, the character is following me. Okay, this is extremely easy to do. You can do so much using just the input class. All right, now I want to do something a little bit more advanced. I want to actually move the character and collect the star when my player and the star collide. You can imagine there are rotation involved, doing the actual math ourselves to make sure that the two objects are actually colliding can be quite complicated. And you don't want to do that when you have a game engine that actually can do it for you. In order to do that, you need to create your scene in a particular way. So you need to use Area 2D, that is an object that the GameDot framework provides, and this object exposes signals, I'm going to talk in a moment what they are, to actually manage collisions. Okay? Inside the Area 2D, you position your sprite, and alongside that, you position a collision shape 2D that define basically the boundary of the objects. Collision shape is exactly what define the actual border of the object that is used by the physics engine to understand when the object is being, touched or not, when something entered the object or not. And collision shape 2D can be of different shapes. And you can specify the shape using the shape property. You can select a rectangular shape, a circular shape, or any other shapes provided by the framework. In this case, because my character is a rectangle, I'm going to use a rectangle. And as you can see, you can actually adjust this rectangle to make it as big as small as you want. And you can add as many collision shapes as you want. And the game engine will all take that in consideration, especially if the character is quite a complicated thing. It's not just a single sprite. And I did the same for star, but I've used a circle shape 2D instead of a rectangle one. So this is kind of a pattern. You can use an Area 2D with a sprite and a collision shape to kind of define any object, and then you can leverage the collision detection capabilities that GoDot can provide. Signals are quite important in GoDot, and in C# they are just delegates. Signals is just a way to subscribe to particular events that an object provides, and you can see them here in the editor. I prefer to use the code to actually hook up to events. That is exactly the same way you subscribe to an event in C#. So let's do that. So if I go in the code, if I look at star, the first things I want to do is to get a reference to the actual Area 2D inside my star. So let's do that using the getNode method. We now know very well. The name of the area is Area 2D. Now I got a reference to the Area 2D. If I try to see what Area 2D exposed, there is a method called AreaEntered. So this AreaEntered is basically an event that Area 2D exposed that I can subscribe to. So if another area is entering this area, I will get notified. And I can subscribe to the event like you normally do in C#. And there we go. So here, I can get a reference to the actual area that is entering my area, and then I can do some code. If you want, you can notify the area, call a method on the area so that you can, for example, change the score or stuff like that. I'm not going to do any of that. The only thing I want to do is to make this kind of star disappear. And there is a method in the framework that is called QFree that basically remove this node completely from the game. And that's what we want. So if I run this game again, when I go with my character on top of a star, it disappears. So it's basically simulate collecting star. And that's fantastic. I didn't have to do any of the complex math to make this work. As you can see, automatically GoDot is figuring out, based on the rotation, the intersection between the circle and the rectangle of the two areas. And the only things I had to do is just simply subscribe to the area entered event. Fantastic. The last things I want to do is to change the color of my star when the mouse goes on top of my star. And as you probably guessed, you can do this very easily using another event that is mouse entered. When the mouse is entered, what I want to do is, let me get my reference to the sprite. And this is called sprite. And I modulate it using the colors yellow. But I also want to do, when the mouse exits my area, I want to revert this back to the white color. Simple as that. Let me run it. When my mouse goes on top of the sprite, the star, it goes yellow, and as soon as it goes off, it's white. And you can just do that with anyone. So now I have a full control of my game. I can move my character, collect things. I can handle rotation, translation. I can handle the mouse. I can make it bigger, smaller. And that's quite awesome. So now you know how to control the keyboard, the mouse, and also manage complicated collision detection using the GoDot physics engine. Thank you very much for watching.